In this unit, we're going to be looking at prisms and shapes that are not prisms. So let's look at the difference between what a prism is as opposed to what not a prism is. Hopefully you can see one big difference, that most of the non-prisms shown come to a point at the top. So to be a prism, there has to be kind of a front and a back that are identical, or a top and a bottom that are identical. Now you'll notice with the cylinder, it does have a top and bottom that are identical. So they have identical circles, but it's not considered a prism because it's circular. But other than that, it does pretty much fit into the category of prisms. When we are working with finding the volume of a three-dimensional object, we have to really be able to identify what is considered the base. Now, in the previous screen, we talked about what it takes to be a prism. And to be a prism, you have an identical front and back, or an identical top and bottom. And that part that is identical is considered the base. So for example, with the cylinder, it has a circle on the top and a circle on the bottom. Those are identical circles, and those are considered the bases. Even if the cylinder was sitting on its side and the circles were in the front and the back, it's still considered the base, because the base means that it has an identical part that matches it. With this triangular prism, it's the triangle that's the base. So you can see that they're identical. You can kind of take slices of triangles. Over here we have a pentagonal prism, and it has a pentagon in the front and in the back. And for a rectangular prism, any side can be considered the base, because if we look at this side, it has a matching side over there. But this part down here can also match up there. So you're noticing that with a rectangular prism, there's a little bit more freedom for what's considered the base. Oftentimes kids think of volume as just length times width times height, and I want us to really get beyond that as our understanding of volume, and really understand why length times width times height works for rectangular prisms, and how we apply the idea of volume to something that's not a rectangular prism. So you can see in this picture that it's kind of got one layer of cubes in the bottom. So the first question is asking us, what is the area of the base? So if we were just to look at the bottom part of that rectangular prism, the area would be a 4x4. So it would have an area of 16 units squared. Now the volume of the base layer just means if I put one layer of cubes down, like shown in this picture, if I just put one layer of cubes on that area, what would be the volume? So how many cubes fill up one layer of the base? And you can see that again, it's 16, but this time my label is going to be cubic. So it's going to be units cubed. So I can fit 16 cubes on the bottom layer. And the next question, how many cubes would you need to fill the prism? So that's why it's really important to think of volume as more along the lines of layering cubes than just length times width times height. So we can fit 16 along the bottom, but you can see that we would have 9 layers. So we would have 9 layers going up, and essentially 9 groups of 16. So 9 groups of 16 would give us 144 cubic units. And that would be the volume of this rectangular prism. So to find this volume of the triangular prism shown, again, we would think about stacking it with layers of cubes. So looking at our questions, it's asking us what is the area of the base. So if I just think about the area of that triangle on the bottom, it's a 4x4 triangle. So the base is 4 and the height is 4, but since it's a triangle, I have to divide by 2. So that means that the area of the base is 8 square units. Now, when we think about volume, we think about placing cubes on that like bottom layer. So the number of cubes that would fit on that bottom layer would be 8 cubic units. So the base layer has a volume of 8. And again, we're going to fill it so that we have 9 layers. So we have 9 groups of those 8. So altogether we have 72 cubic units. 72 cubes would fit in that prism if I was to stack them all up. All right, take a minute and answer these 3 questions on your own, and we'll check in together and see how you did. All right, to find the area of the base, this base is a triangle. It has a base of 3 and a height of 4, and divide by 2. So 3 times 4 divided by 2, so 6 feet squared. The volume of the base layer would be 6 feet cubed. So I'd be able to fit six cubes on that bottom layer. And then I'm looking at how many slices I have. So if I look at this image, I can see that I would have 3 slices of 6. So 6 times 3, you should have gotten 18 cubic feet.